Hey, what's up, everybody? It's Miss Brothers. Hey, just going to take you through these problems on our molar mass practice number 2. So when we do stoichiometry, like I said, this is the process where we convert between units in chemistry. Okay. Right now we're starting with the easy one. We're doing a one-step process, and specifically we are converting from grams to moles or moles to grams. So with this first part, what we're doing is we are essentially converting from grams to moles. And in part 2 of this, we're going to do just the opposite. We are going to convert from moles to grams. All right, so let's go ahead and start part 1. And I'll just kind of take you through the whole thing, so bear with me. Now, for this one, we have the unit of grams, and we have to find the unit of moles. So for 1 through 5, we know that all of our answers, the unit that we're going to end up with is moles. And to start with, everything that we're given, the unit we are given to start with is grams. Grams, 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 grams. Okay? And because in our T-chart, we always set up with the unit we are given. We are given grams, which means we're going to put 25 grams of NaCl into the upper left-hand part of our T-chart. Oops. We're converting to moles, which means that has to go at the top here. And the unit that we're going to have down here is going to be grams of NaCl. Now, right now, we don't know how many grams of NaCl we're going to need for 1 mole. So we have to calculate that. And we're going to do that by using our formula. We've got Na. I'm just going to put this over here in the corner. Actually, you know what? No, I'd take that back. I'm going to use that piece of paper like I did in the last practice. So, and this is just a way for us to more easily see this. So we have NaCl, and we have to calculate what the mass is of 1 molecule of NaCl, because that's what we have. So we have Na and we have Cl, and we've got 1 of each, 1 times 1. And if we look at the periodic table, we know that sodium has a mass of 23.00 grams, and we know that 1 atom of chlorine has a mass of 35.45 grams. We need to find the total mass of this molecule, so we have to add these two masses together. And if we add them up, we end up with, what is that, 0.45? That's 58.45 grams. So that's going to be the number that we fill in right here, 58.45 grams. And now that we have our problem set up, we can go through and we can cancel our units. So we're going to cancel this grams of NaCl, and we're going to cancel this grams of NaCl. So we're left with the unit of moles, and I'm just going to write that right over there. So now what we have to do, actually, I'm going to write that a little bit farther over. I might as well use all this space since I have it. I'm going to take 25 times 1, which is another way of saying 25 moles, make that look like a 5, over 58.45. And again, you guys, I don't have to worry about the units because I've already canceled out my units. So now it's just a matter of doing that math. And when we do that math, we end up with 25 divided by 58.45, which leaves us an answer. We're going to round this to the nearest hundredth, so that's going to be 0.43 moles of NaCl, otherwise known as sodium chloride. All right, so far so good. And again, you guys remember, we're trying to solve for moles. We have mole as our final unit, so we know that we're on the right track. So the next one, we are given 125 grams of H2SO4, which is sulfuric acid, H2SO4. And we're setting up our T-chart. We know we have to end with moles, so we're going to end up putting 1 mole right at the top here, just like we did before. And that's going to be of H2SO4. And we know that we're going to have to be able to cancel this out, so 1 mole, we're going to have to put grams of H2SO4 over here. And so now we have to calculate the quantity that we fill in right here. So again, let's go ahead and head over to our handy extra sheet of paper. We know that we have 1 molecule of H2SO4, which means we have some hydrogen, it means we have some sulfur, and it means we have some oxygen. Now, how much of each one? We've got 2 hydrogens, so 1.01 times 2 of those equals 2.02 grams of hydrogen. we only have one sulfur, so we've got one of those, and the atomic mass of sulfur is 32.06 grams, so that's what we're going to put over here, 36.0. What did I say? 32.06. Getting all my numbers mixed up here. 32.06 grams, and of course we have oxygen, and that subscript tells us that we have 4 oxygen, so times 4. And then, of course, we have times 16.00 grams because that is the atomic mass. And if we do our math there, we end up with 64.00 grams of oxygen. And once we add all that together, we end up with 158. Oops, I did that wrong. Let me double check my math here. Oops. I'm struggle bussing. 2 plus 32.06 plus 64. That's more like it. That is 98.08 grams. And that's the quantity that I'm going to fill in to this space right here. 98.08 grams. So now it's just a matter of going through and canceling our units. We're going to cancel. We're going to cancel those. And that's going to leave us with 125 moles over 98.08. And once we do the math on that, 125 divided by 98.08, that leaves us, and again we're rounding this to the nearest hundredth, 1.27 moles of H2SO4. And that is what we're going to circle. Oh, I forgot to circle my first one. That's no good at all. All right, let's do our next one. And again, we are given grams, so that is what we are going to put in the upper left-hand part of our T chart, 100, and I'm going to go ahead and put 100.0 grams of potassium magnesium oxide, MnO4, manganese oxide, there it is. And again, setting up my T chart, I've got 1 mole of KMnO4, and over the top of that, I know that this has to be grams of KMnO4. However, I don't know what my mass quantity is. I have to calculate it using my formula. So let's go back here. So I've got KMnO4. Double check, make sure I wrote that formula right. KMnO4, I did, which means I have some potassium. I have 1 potassium. I have 1 manganese. And I have 4 oxygen. So now it's just a matter of going through and finding my atomic masses. So my atomic mass of potassium is 39, and this is rounded, 39.10 grams. My manganese, and again rounded, 54.94 grams. And I've got 4 oxygens times 16, so just like the last time, it's going to be 64.00 grams. And if I add that up, I've got 39.10 plus 54.94 plus 64. That gives me 154.08 grams. And that will be the number I put in right here, this little space that I have left for myself, because I like to leave space for myself. 154.08. Guess what time it is? It's canceling time. So let's go ahead and cancel these and cancel those. And what I'm left with is moles, specifically 100.0 moles of KMnO4 over 154.08. And once I do the math on that, 100 divided by 154.08 equals, double check my math here, yes, I end up with, did I do that right? Something doesn't look right about that. Let me try that again. 100 divided by 154.08. Yeah, so that leaves me with 0.65 moles of KMnO4 MnO4, and that is the answer I am going to circle. All right, looking good. All right, and then we're on number 4 here. So again, if we are continuing to look at this, we are trying to get to moles. The unit we are given is grams, so we're going to put 74 grams of potassium chloride, KCl, right here. Setting up my T-chart. I know that I have to have grams down here. I know that I have to have 1 mole. Notice the trend here, you guys. 1 mole, 1 mole, 1 mole, 1 mole. And that's because we are doing the molar mass of each of these compounds, okay? So we have 1 mole of KCl. Down here, we have to be able to cancel this unit of grams of KCl, so we're going to write grams of KCl down here at the bottom. And now we just have to calculate what that number is going to be. And this is a relatively straightforward one because we've only got a couple of different elements in this one. Here it is, KCl, which means I have a potassium and I have a chlorine. And if I'm looking at that, my atomic mass of potassium is 39.10 grams, and my chlorine is 35.45 grams. And I can just look at my previous problems if I want to get those numbers. And then when it comes to doing the math on that, we end up with 74.55 grams of KCl. So again, let me double check my math there. Yes, 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 74.55. So that is going to be the quantity that I write right here, 74.55 grams of KCl. So again, it's canceling time. Going to cancel out the grams of KCl. I'm going to do my multiplication across my table here, my T-chart. So I've got 74 moles of KCl over 74.55. Go ahead and do my math there. So that's going to be 74 divided by 74.55. And if I'm rounding this to the nearest hundredth, it's going to be 0.99 moles of KCl. Fantastic. All right, let's do this last one of Section 1. And again, Section 1 tells us that we're trying to find the moles if we are given the mass of a particular substance. Now, this one looks freaky, but don't get freaked out by it, because we actually treat these things separately and together all at the same time. You're like, what does that mean? Well, I'm going to show you what it means. Don't panic, because really the only thing you have to remember to start with is that you have to start with grams because you're given grams, and that's what we're going to put into our upper left-hand part of our T-chart. So 35 grams of CuSO4 times 5 H2O. Whew, that's busy. And we're going to go ahead and set that over 1. Set up our T-chart. Hey, guess what goes up here? Yeah, 1 mole of this big boy, 6U, or copper, SO4, copper sulfate, and water, 5 molecules of water, over, and again, because we have to be able to cancel out grams of this, we're just going to say this chemical formula. So we have to put this over grams. We don't know how many grams yet. We're going to calculate that in a minute. Grams of CuSO4 times 5 H2O. So we are absolutely going back to our piece of paper because we have to calculate the mass that goes right in that spot right there. Let's do that. So as far as this again, I have CuSO4 times 5 H2O. So like we've done before, we've basically just been stacking what's in our compounds and then calculating the masses as a result of that. So let's do that right now. So we know we have a copper, so let's go ahead and put our copper here. We have a sulfur. How many coppers do we have? We have 1 copper. We have 1 sulfur. We have 4 oxygens. Now let's do this because we've got a lot of we've got oxygen here and we have oxygen here. And so actually what we have to do is we have to add all the oxygens together. So I've got 4 oxygens here. Because of this coefficient, I have 5 oxygens right here for a total of 9 oxygens. So oxygen is going to be times 9. Ooh, that's busy. And then finally, the last thing I have yet is my hydrogen. And I have 2 hydrogens in water, but I have to remember, because of this coefficient, I have to multiply 2 times 5, which gives me hydrogen times 10. So now I have to go through and figure out what's the mass of each of these things. So if I look at copper on the periodic table, I see that it has a mass of 63.55 grams, because I only have the 1 atom of it. Sulfur, if you remember, is 32.06 grams, because I only have the 1 atom of sulfur. Now I've got 9 oxygens, so essentially what I have to do is I have to take 9 times 16, and when I do that I end up with 144.00 grams, and I have to take hydrogen times 10. So I'm going to take 10 times 1.01, because that's hydrogen's mass, and then I end up with 10.10 grams. So let's add all these up and see what we get. So we've got 63.55 for the copper, 32.06 for the sulfur, 144 for the oxygen, and 10.10, which gives me a total of 249.71 grams. So this is the entire mass of this whole thing right here. And that's exactly what we're going to fill in. This is going to be 249.71 grams of this entire chemical formula, the copper sulfate plus the waters together. So again, you guys, it's not super complicated. We're just going to go through and cancel our unit, get rid of all of that, and then we can get rid of all of that over here. That leaves us with this mole and this unit right here, so we can do our multiplication across our table. So this is going to be 35 moles of CuSO4, 5H2O, over 249.71. So let's go ahead and do the math on that. So that's going to be 35 divided by 2, 49.71 equals, and if we go ahead and do this to the nearest hundredth, we end up with 0.14 moles of CuSO4 and 5H2O, and that is what we're going to circle right there. So there you go. So that's part 1. Part 1, what we did is we were given the masses of different substances, and it was our job to figure out how many moles. Okay? And again, you guys, moles is a quantity in each quantity, and this mass is another quantity. So we were looking for the number of moles in a particular mass of a substance. So part 1. We'll come back here in a second, and then we will do part 2. All right, let's go ahead and dig into part 2. For part 2, you guys, what we have is we are trying to determine the number of grams if we are given the number of moles of a particular substance. The nice thing is that these substances are exactly the same as the substances in the previous 5 problems, which is nice because then we don't have to go through the process of calculating the masses of these substances. Again, we can just go back up into these problems and find those masses, and that's going to speed up the process. So let's dig in. So for number 6, we start out with 2.5 moles, I should make that look like a decimals, of NaCl. And again, because we are setting up our T-chart, this one ends up at the top left-hand corner. I'm going to set that quantity to 1. Now I have to be able to cancel moles out, and because I'm doing molar mass compared to 1 mole of any substance, we know that we're going to put 1 mole down at the bottom. There had been some confusion earlier about what number you put in this spot right here. Remember, you guys, molar mass means we're taking the mass and comparing it to 1 mole of stuff. Okay, so it's 1 mole. And remember that if we go back to our first problem, we determined earlier that the mass of 1 mole of NaCl is 58.45 grams, so that's what we're going to write here, 58.45 grams of NaCl, and I'm going to remember to put NaCl down here at the bottom as well. And now what I can do is I can go through and I can cancel my units of NaCl, so moles of NaCl, moles of NaCl, and now it's just a matter of multiplying 2.5 times 58.45 grams of NaCl. I'm just going to go ahead and write that there so I have my unit nice and ready for me, and I'm just going to do a little math. So let's go ahead and get a calculator going here, and I'm going to go ahead and take 52.5 times 58.45, and it looks to me like I end up with a quantity of 146.125 grams, and I'm going to go ahead and just round that to the nearest hundredth, which is going to give me 146.13 grams of NaCl. So that means if I start with 2.5 moles of NaCl, it's going to be the same as saying that it weighs 146.13 grams. Sweet. Let's go to problem number 2. With number 2, we've got 0.50 moles of sulfuric acid, H2SO4. And again, we're going to set that quantity over 1. And again, we have to cancel out moles, so 1 mole of H2SO4 is going to be our unit down here, mole. We know that we're going to have grams up here, grams of H2SO4, because again, we're trying to determine the number of grams. And again, according to problem 2 at the top, the molar mass of H2SO4 is 98.08 grams per mole, so 98.08 grams. And again, we're ready to do a little bit of math here, so 0.5 times, well, I guess I'll do that, so that's 0.50 times 98.08 equals 49.09 is what we get, so 49.04, is that what that says? That's exactly what it says. Grams of H2SO4, and again, having to remember to cross out, cancel out those. And so that is my final answer right there. We're cruising right now. All right, I have 1.70 moles, 1.70 moles of KMNO4. And again, setting up my T-chart over 1. I have to cancel moles, so I'm going to put 1 mole of KMNO4 at the bottom. And on top, I'm going to put grams of KMNO4. How many grams? Well, let's go up to number 3. And if you remember, we calculated this earlier, and the mass that we calculated for a molecule of that, it's 154.08 grams. So 154.08 grams. I can go ahead and I can do my canceling. So I'm going to cancel my moles of KMNO4 here. I'm going to cancel my moles of KMNO4 there. And now I'm ready to do some multiplication. In this case, I'm going to multiply 1.70 times 154.08. And that gives me 261 point, and I'm going to round this 3 up to 4, 261.94. Wait, I have to make sure I did that right. Did I do my numbers right on that? Oh, gosh, let me see. Did I get that right? 154.08. I got something different when I originally did this, so I'm just double checking my work. I think I might have added wrong. I think I forgot my 1 out here. Let's do that again. 1.70 times 154.08. Yeah, that's what I got again. All right. I wonder if I did it wrong the first time. Just making sure I did my math right. Sometimes I do math wrong. Well, if I'm wrong, you guys will let me know. That's for sure. All right. And let's go ahead and do my units. That is grams, KMNO4. Now, see, that's going to bug me now. I've got to make sure I set that up right. 1.70 times... Oh, you know what? I used the wrong quantity. That's supposed to be 158. No, that's why. I did the wrong quantity up here. Did I? I'm sorry, you guys. I'm all distracted now. Give me 1 second. 39.10 plus 54.94 plus 64. 158.04. So when did I did it wrong? Oh, I did it wrong earlier. So that's actually supposed to be 158.08. Oh, I see. Oh, I see what I did. I transposed the 4 and the 8 there because I've been working with way too many numbers today. That's all right. So, yeah, you guys, sorry about that. I messed up this one up here. So, yeah, like I said, my key is right. My video is wrong. Sorry. I'm still a good person, though. I swear. All right. 1.70 times 158.04. That looks more like what I got this morning, so yay for me. So that's actually going to be 268.67. 67 grams. I'll have to go up and fix that one later. Yeah, I probably won't. Sorry. I'm the worst. All right, moving on. Let's go do number 9. So I have 0.25 moles of KCl. This is tricky, you guys. Just remember, in terms of what combines, you don't often see carbon combining with iodine, so it's not. This is actually the compound potassium chloride. So this is actually chloride, so just know that. Over 1. And again, we're going to set 1 mole, and according to this, our mass of KCl is 74.55 grams. And again, it's KCl and KCl. Got to get those units, otherwise nothing cancels, and we got to make sure stuff cancels. So we're going to cancel out moles of KCl here, moles of KCl here, and we're going to take 0.25 times 74.55 equals 18.64, and that's going to be grams of KCl, and that's going to be my final answer there. All right, you didn't think we were going to get away from this giant unit yet, did you? Not quite. So, but this time, you guys, we have 3.2 moles of copper sulfate and 5 molecules of water, so CuSO4. And 5 molecules of water. And again, we're going to set that over 1. So down here, we're going to have 1 mole so that we can do our canceling. And over here, I forgot my units, CuSO4, 5H2O. And on top, we're going to have grams of CuSO4 and 5 molecules of H2O. And again, if you remember, we're going to use this quantity that we determined earlier, 249.71. So once I do the math there, I'm going to end up with 3.2 times 249.71, 249.71, and that gives me 799, and we're going to go ahead and round that to the nearest hundredth, which is going to give me 10 grams of CuSO4 and 5 molecules of water. And there you go. So like I said, this part goes a little faster because we didn't have to redetermine these masses. We just used the masses that we calculated for the top half of this. And again, just remembering, the big thing to remember is when we're dealing with molar mass, it's any mass over 1 mole, or it's 1 mole over any mass. So the key to remember is that when we're doing molar masses, we're comparing these different masses to 1 mole of something. So when you're setting up your formulas and you're setting up moles to be canceled out, just know you're setting up 1 mole in this particular type of problem. All right, well, hopefully that was helpful to you. If you have any questions, let me know.